Dear students and participants of the course on railway engineering, today we are going to discuss again the fastenings. The focus of today's lecture is the rail to sleeper fastenings, and within those we will be first of all talking about the elastic fastenings. If you remember, in the previous lecture we started discussing about the fastenings, and the very first thing which we have taken up was to connect the rail with the rail. And in that case, the different type of fastenings have been discussed. We talked about the standard fish plates, we talked about the joggled fish plates, we also talked about the combination fish plates which are required when two different type of rail sections are being jointed together. And we have taken an example, say 52 kg per meter rail section and a 60 kg per meter rail section. If they have been combined together, then what needs to be done and how it can be done. Now, when we talk about the fish plates, the another important aspects which we have discussed at that time was the use of bolts and nuts. Without these, the fish plates cannot be bolted to the rail sections. So, the specifications of bolts and nuts and the permissible limits which have been provided in terms of tolerances have also been discussed at that time. Now, taking this discussion forward, today we will be taking up the fastenings which are required to connect rail with the sleeper. In this particular case, the very first thing, as I said, we are going to talk about the elastic fastenings. So, we will look at what are the requirements of those elastic fastenings. And when you say these requirements, we may be talking about the various physical or the engineering characteristics which should be there when we use these elastic fastenings. And in today's lecture, the focus will be with the rubber pads, and these rubber pads, they can be grooved rubber solo pads, or they can be the composite rubber pads, or they can be the nylon cord rubber pads. All of these particular cases, the grooves are going to be provided, and that is where the G which is being used in all of these cases, that symbolizes it. Starting with the requirements of the elastic fastenings which can be provided. Now, when we say these are elastic fastenings, it means they have been able to take up the loads which are coming either in the vertical direction or the lateral direction or the longitudinal direction, and they remains there without having being disturbed or deformed or being cracked because of those particular loads which are coming, and they keep giving their services as per the requirement. In that sense, the very first thing is that whatever type of elastic fastenings are used, they should be able to hold the gauge well. That means when you are talking about the two rail sections, see, we are talking about the rail section here, or we are talking about another rail section the other side. So, this particular distance is what we are talking here, the gauge. It should not happen that when this rail is being placed at the top of any type of sleeper and is being either clamped or being used, there are inserts which have been used here, so that this rail remains fitted with the sleepers. In whatever the cases, with the interaction of wheel and flanges and the rail head, it should not happen that this gauge widens up. So, this is another important aspect which needs to be there. Another thing is the adequate toe load should be there. Now, when we say this adequate toe load, now this toe load is going to be there because of the clips which are being provided here, and they are putting the pressure at this point. So, there is a specific pressure which needs to be inserted, which needs to be created at this particular location. If it is not there, then this rail will not remain in position, it will remain loose, and with the interaction of the wheels and the flanges, there is always a possibility that it will start moving. So, that is where the importance of the toe load is there, and when we will talking about these type of fastenings, say the clips, we will see that different amount of toe loads are there which can be provided by use of different type of clips. They should provide the sufficient elasticity to absorb the vibrations and shocks. And when we say that we are talking about the vibrations and shocks, we are basically interested in that there should not be any loosening. So, if there is a loosening of these particular fastenings, then the function is lost. They should maintain the track well. Of course, we said that it is going to maintain the gauge when it is going to maintain the connection of the rail with the sleeper. So, here as we say this is sleeper and this is the rail. So, if everything is being maintained perfectly, it means the track is being maintained perfectly. So, that is the idea here. Adequate resistance to the lateral forces, thus to provide the stability to the track. So, the lateral forces I already said that if there is a flange of a wheel, so there is an interaction here, and this will be happening on the other side also depending on the lateral movement of this bogie, lateral movement of the wheel base. So, if these type of forces are being exerted, there is always a possibility that it will topple in this direction. There is an overturning which may be there. If you remember, we have talked about the longitudinal stresses, we talked about the vertical stresses, we talked about the lateral stresses and forces which gets induced in the rail sections because of all of these type of actions. So, this is also an important aspect. So, all these fastenings which have been used at this particular junction, they should be such that they keep the rail into position and there is no impact of those lateral forces in terms of the movement of the rail outwards. Adequate resistance to the longitudinal forces. And when we say longitudinal forces, it means we are interested to see that the creep which may get induced is being resisted. So, that means we are talking the movement in this direction. And why this is going to happen? We have already discussed that when the two rail sections which have been jointed. So, these are the two rail sections R1 and R2, and they have been jointed here maybe by using a fish plate or it can be a welding. If it is a welding, there is no issue, there are no problems as such, but when there is a fish plate being used, it means there is a gap, and because of the interaction at this particular gap of the wheel, there is always a possibility of the forces which are acting on the rail end. And if that happens, then there is also a possibility the rail will move in a particular direction. And this movement will depend on number of factors. If you remember, we did talk about all of those factors when we have discussed about the longitudinal movement, that is creep. So, here the point is that if this type of a thing is happening, then there is a problem. So, whatever the fastenings which have been provided at different locations, see these are the locations of sleeper 1, sleeper 2 and so on. So, at this point if they have been connected together, so these particular fastening they should be able to keep the rail in position, there should not be a movement in the longitudinal direction, and that is where we are containing the creep. So, this is another aspect. Then another thing is they should be fit and forget type. When we say fit and forget type, it means once they have been inserted, once they have been placed in position, then there should be no requirement of a maintenance. But it is very difficult to have a material, it is very difficult to have such an ideal situation or a condition where the maintenance may not be required. So, that is where we are using a word here, the least maintenance. So, once they have been put in place, the maintenance requirement should be at a long interval. And when we say long interval, it means we are talking here about the service life. We can say that they should have a long service life. So, if that is there, then it is a good condition. And this long service life is going to be controlled by the characteristics. And these characteristics we can say they can be the physical characteristics or engineering characteristics. So, these together they will contribute to the service life, and if the service life is more and they have the adequate strength or resistance with respect to the lateral forces, longitudinal forces, that means the maintenance is also going to be lesser. They should be reusable without the loss of properties. So, it should be a possibility that because of some reason at particular location they have been taken out, then there should be another location where it can be used. So, this is an aspect. Easy to manufacture, easy to lay, as well as easy to maintain, all the three aspects. The design should not be complex design. The item which has been provided at the field should be such that the staff, the manpower, the equipment which is available at the location, they can use it very easily. They can lay that particular device or item in between the rail and the sleeper. And finally, whenever there is a requirement of maintenance, it should be easy to take it out and replace or reuse. They should be free from sabotage or theft. This is one of the big problem. It has been observed that because of this reason, specifically related to fish plates and bolts, these are being taken out, and if these have been taken out, then this is a location where there is always a possibility of a derailment. We have discussed about the joints. We discussed about that if there are fish plated joints, then they are the points of weaknesses. There are points where there are a number of things which may happen, get induced in terms of buckling, in terms of hogging, in terms of the possibility of the longitudinal movement of the rail. So, all of those things we have discussed. So, this is another important aspect. Either they should not have a value in terms of a scrap, or they should not be able to be taken out in a manner that anybody can take out without having special tools and then create a problem to the railways. They should be universal type. Universal type means they can be used with any type of a track, with any type of a rail section. If it is possible that if we can use it with 52 kg rail as well as a 60 kg rail, probably that is going to be the best thing which can happen, because in that case we are going to manufacture only one type of a fastenings, and then it is going to be used at different location. It is going to be used for different rail sections. The low cost and long service life. I already talked about the service life here, that the service life should be long enough, and when we say the service life is long enough, we usually talk about that it is compatible with other items or components. And when we talk about this, we can say that we are talking in terms of maybe rail, in terms of sleepers, because these are the two things where these have been used. So, if all of these things are compatible in terms of their service lives, then that is a good proposition. Now, coming to the different type of fastenings. The first one which we are taking is a rubber pad. Now, here you can see there is a rubber pad being shown. Different dots you can find on that particular pad, and if you look at on the side, then there are grooves being provided in that rubber pad. So, if you are looking from a particular side, you will find that there is a grooving being done. So, these rubber pads, they are manufactured using different type of materials. It all depends on that what are the location, what is the function for which it is to be used. So, it can be used for a natural rubber, it can be the ribbed smoked sheet defined as RSS, and in this particular case there can be 4 grades, grade 1 to 4, or it can be blended with the styrene butadiene rubber SPR, or it can be polybutadiene rubber PBR. So, you can see there are different possibilities, different type of chemicals which can be used so as to manufacture these rubber pads. Now, the another one can be the nylon cord reinforced GRSP. So, these are basically grooved rubber solo pads. and these shall consist of two layers of the same compound of GRSP. So, that means when talking, so there is one layer and another layer, and it is reinforced in between with two layers of treated nylon cord and a thin rubber layer between the two layers of the reinforcement. That means number of layers are now going to be incorporated here. So, if we talk in that form, we can say that this is a sort of a condition where the nylon cord reinforced, this consists of first of all layer 1 and layer 2. These layer 1 and layer 2, they are of some compound, there is a compound A and compound B. So, this is of GRSP, and then in between that what we are putting a treated nylon cord. So, this is a nylon cord and this one is a nylon cord, and then in between the nylon cord what we are putting is a thin rubber sheet here. This is a thin rubber sheet. So, this total composition if we take will provide you the overall rubber pad. Now, what are the functions of this rubber pad? Now, when we are using this rubber pad at the base of a rail section, so the rubber pad is going to be placed here, this is rubber pad, and then we have the sleeper, and here this is rail section. So, whatever are the shocks which are going to be there at the top on the rail head, see there is a vertical movement of the bogie or the wheel, and because of that the pressure will come here. Now, this pad will absorb that shock, and as soon as this is over, then it will come back and it will bring everything to the normal situation. Another thing is because of its nature, because of its property, this will resist the longitudinal movement of the rails. Now, when it is resisting the longitudinal movement of the rails, it itself will not be able to do that. There will be other requirements like sort of some inserts which needs to be used so that everything remains intact in position and it gives its function. Now, as we talked about the shocks which are coming say in the vertical direction, there can also be a possibility there are movements in this. So, any type of vibration which is getting induced in the rail section, this should have a property that it dampens that or it absorbs those particular vibrations, because if these vibrations are not being dampened, then all of these fastenings in terms of the connecting of the rail and the sleeper, they may get loose, because continuous those vibrations they will create a problem. It should prevent the abrasion of the rail on the top of the sleeper. So, there is no direct contact now, there is a difference here that this is the rail bottom and this is the top of sleeper. Now, when these two things are not in contact with each other, so whatever the problems which could induce at this particular point because of the rail seat will not be there. It acts as an insulator between the rail and the sleeper. So, this is another property obviously because of the material which is being used here, as we talking here about a rubber or a different type of rubbers with the chemicals. So, that insulation will be there. The sizes are 130 mm by 125 mm by 6 mm with the grooves at 11 mm center to center and 3 mm deep on either side, alternatively at top and bottom. Now, if we see here, there is a groove being shown. If you look at it very minutely, you will find that the grooves are there. So, there continuous grooves are being provided. But when you talk about the reverse side, then this alterations has to be done. So, it is talking about the size, it is talking about 130 by 125 and the thickness is 6 mm. There can be different other thicknesses also. And then the grooves which have been provided, what is the distance of these grooves, it is being also discussed, that is 11 mm. And then the depth. So, if you remember previously when we were talking about the section, then it was like this. So, the depth is also being talked, this depth is 3 mm and this is on either side. Now, suppose if we are talking about the 6 mm deep this rubber pad and the depth is 3 mm for the groove, then there cannot be a possibility that we have both the grooves coming at the same location. So, then this is going to be a problem. So, if we have a groove here like this, then at the bottom the groove will be at another location. So, that is how you will get always a 6 mm thickness. So, here you can see that how the grooves have been provided. You can also see the thickness and you can also see that how the layers are being provided, and in between at the center there is a thin rubber layer which is being used. Now, this composite grooved rubber solo plates or pads which are there, they consist of two layers of different rubber compounds and they are being named as compound A and compound B. Now, thickness of compound is 6.2 mm for this composite GRSP. In the case of compound A, it is roughly 3 mm, and in the case of compound B, it is around 3.5 mm. Overall means around 6.2 mm of the thickness is going to be there for these composite systems. The tolerances are also being defined for the thicknesses, and these tolerances are plus 0.5 mm to minus 0 mm. That means it cannot be less, but there is a possibility that you can have a bit higher of the thickness being provided. There can be a 10 mm rubber pad also, and this 10 mm composite rubber pad, in this particular case there will be a compound A of 7 mm and compound B of 3 mm thickness. That is how it becomes 10 mm. And then along with that the tolerance is also being defined, and this tolerance is 0.5 mm plus minus in both the cases. Overall, for the thickness of the CGRSP, the tolerance is plus 0.7 mm, but it is no tolerance in terms of the lower limit, it means it is 0 mm. So, there cannot be any compromise. Now, all of these things, if you are interested to read further also, you can always look at the RDSO specification, that is T55 2022, from where the data has been taken. Now, let us talk about the physical properties of the rubber pads, and here we are comparing 6 mm rubber pad and the 10 mm rubber pad, that is a grooved rubber solo plates. The various properties which are talked, the first one is the hardness, and the hardness in the case of 6 mm needs to be minimum 75 A, but in the case of 10 mm it can be 70 A. In the case of the tensile strength, which is being taken as kg per centimeter square, and it is at a time when the new rubber pad has come, as well as at a time when the rubber pad is already being used. It has got aged because of the environmental conditions, because of the loading conditions, because of the different other type of thing which is happening in terms of a deterioration. So, two values are being talked, one is before, another is after aging, and that is 120 kg per centimeter square and 100 kg per centimeter square respectively. And what it says is, in that sense, the retention of the tensile strength shall not be less than 80%. And the same value is being used here as 120 and 100 kg per centimeter square for a 10 mm thick GRSP, and this has to be GRSP. But the retention here is being talked that the minimum value which can be there is 70% instead of 80%. Elongation at the break, it is 200 before and 150 after aging. Again the retention is being talked as 65% in the first case and 60% in the second case. Then the next property is the relaxed modulus at 100% elongation, and this relaxed modulus at 100% elongation is being taught again in terms of before and after, but when talking about after, it is being taken in terms of a percent change. So, what it says is that its value can be between 45 to 60 kg per centimeter square before, but the change which can come is either plus 30 or minus 10% after aging. In the case of 10 mm, the values are a bit higher, they are 50 to 75 kg per centimeter square before aging, and in terms of a change, it is a constant value as plus or minus 40%. Then compression set subjected to 50% of the compression. Here the maximum values of the compressions are being defined as 30% in both the cases. The load compression, that is being defined as 0.4 to 0.6 mm in the case of 6 mm thick rubber pad, and 0.7 to 1 mm in the case of 10 mm thick rubber pad. The tension which is subjected to 50% of the stretch. So, the maximum which can be there is 25% in both the cases. Then another is the electrical resistance before and after. So, when you talk about that value, it is a constant value for both the cases, it is 100 mega ohms. Ash content, it is plus minus 5 and can go up to maximum 29% in the case of 6 mm thick, and the same value has been also used in the case of 10 mm thick. Specific gravity also the standards are same with the variations of plus minus 0.03 and the specific gravity is 1.27. Second, stiffness is 150 to 250 kilonewtons per mm in the case of 6, but there is some change here, it is 100 to 170 kilonewton per mm in the case of 10 mm thick GRSP. Impact attenuation is 30% minimum or 40% minimum in the case of 6 mm and 10 mm thick pads respectively. Now, the same way as we have talked about these pads, the another type of pad which we have discussed was the composite pad, where the compound A and compound B were used. So, now we are talking about that CGRSP. Here again we have the values as 6.2 mm and 10 mm. Going ahead with the particular values, hardness, here it is being talked as compound A and compound B, different values are there, 75 and 60 for 6.2 mm and they are same in the case of 10 mm. We are talking about the tensile strength. The tensile strength values are again the same, and in fact in this particular case the retention is also the same. Previously it was different. Then elongation at the break, this is 250 before, 180 after aging, and the same value is being used here along with the retention as 60%. Relaxed modulus at 100% elongation, this is 25 to 45 kg per centimeter square before, and then there is a percent change which is plus 30 to minus 10%. If you remember, that is almost the same value which was there previously too, but previously in the case of 10 mm this value was plus minus 40%, but here that is a difference, it is the same value as being talked in the case of 6.2 mm. Similarly, the values are same if you talk about the compression set, which is 30% maximum. The load compression, this is different, it was different previously too. So, it is 0.6 to 0.9 and 0.8 to 1.1 mm. Tension set subjected to 50% of stretch is again same, here 25%. Electrical resistance, previously too it was talked as 100 mega ohms, here also it is the same value. Ash content, it was plus minus 5 and maximum 29%, but because here there are two compounds which have been used, the values have been defined for compound A and compound B. So, 29% is for compound A and 20% is for compound B. In the case of 10 mm, again this is 29% and 20% respectively with plus minus 5%. A specific gravity, previously too it was 1.27 with plus minus 0.03. But here again for the different compounds it is being talked. So, it is compound B, the value is lower as 1.17. Then the second stiffness, this is 100 to 240 and 100 to 170, a change is there. Impact attenuation is 30% minimum or 40% minimum for the two cases. Another one which is being added here, because you are talking about the two layers of compound A and compound B, and they have been jointed together. So, adhesion is being taught in terms of the force with which they are going to remain in contact, and that force is 8 kgf minimum it should be there, so that they remain together. Now, there are some dynamic properties also of CGRSP, and those dynamic properties are resilience at 20% deformation and the minimum value is 80. The static modulus at 20% deformation, it is 55 to 65. The units here are like kg per centimeter square. Effective dynamic modulus at 20% deformation is kg centimeter square. This is 70 to 90, and oscillating decay is 0.35. So, these are some additional things which are there, which were not there in the case of only GRSP. Then some other physical properties which we are talking now is for the third case, that is the nylon cord reinforced, the grooved rubber solo plates. So, there we said that there are going to be two plates at the top and the bottom, then in between the compound A and B were there, and then in between other things. So, here in this case the nylon cords are going to be there, in between the nylon cords there is a thick rubber pad being provided. So, hardness is 75A, that is the minimum value. Tensile strength, again it talks about the same values as we have discussed previously, as 120 and 100 kg per centimeter square, and the retention is 80%. Elongation at break is 200 before and 150 after aging, retention is 65%. Relaxed modulus is 100%, elongation is 45 to 60 kg per centimeter square before, and then there is a percent change, the same value is there as it has been previously, it is plus 13 minus 10%. Specific gravity values are also the same as we have discussed previously. So, certain values remain same, maybe some of the values may have a difference, but most of the things are more or less same. Compression set subjected to 50% compression is 30% here. The load compression is 0.3 to 0.5 for change here. Tension set subjected to 50% stretch is maximum 25%, it is more or less the same value as previously. Then the electrical resistance is also the same as 100 mega ohms, and ash content is plus minus 5 and maximum 29%, and that is the same value as we have seen previously. Then there are few other things which are being specified. So, there is a denier, that is a gram per 9000 meter, in minimum it is 2400. So, that is another property which was not being discussed in the other cases. The number of ends per inch, it is 24 plus minus 2. The thickness minimum 0.75 mm. The load at the break is 16 kg minimum. Elongation at the break is 20% maximum, and the number of twists per meter which can happen, they can be 380 to 400. So, these are again additional values which are there in the case we are using a nylon cord GRSP. Then adhesion between the cord and the rubber, that is being talked in terms of a H pull test, and the value here instead of 8 kgf which we discussed previously, now this is 10 kgf. Peel adhesion is 4 kgf minimum, and the breaking load is 350 kgf minimum, average of 5 specimens, this is what is to be taken, or 352 kg per million for individual specimen. So, here both individual as well as 5 specimen data has been given. There is a possibility of using the metal liners. Metal liners, they are used with the elastic rail clips and basically with the concrete sleepers. Now, if you talk about the mechanical properties of these metal liners, then ultimate tensile strength is minimum 410 MPa, yield strength is 250 MPa, the percent elongation is minimum 23, hardness is 115 HBW, that is an hardness scale, there is a Brenner hardness W scale, there can be Brenner hardness number, there can be S scale also, and all of those it is the same being defined. In the case of bend test for internal dia, it is 2 tons at 180 degree for a U-shape metal liner. CRP impact test, in that it is being defined in terms of the energy as 27 joules, and the fine grains of ferrite and perlite which are being used, they should be 6 or finer. So, these are the various values for metal liners. In the case of glass filled nylon 66 liners, these are insulating liners, They can be of lesser thicknesses as 4 mm and 6 mm, as you can see on the right hand side. The type of gas filled nylon 66 liner has been shown. They are used on the circuited track sections subjected to severe corrosions. So, because of their properties, so they are not getting corroded, available in single piece, free of corrosion, have longer life. They are correlated items with each other. They are used on 52 kg and 60 kg rail sections. So, universality is also there, and in PRC sleepers in coastal regions or in areas which are subjected to industrial fumes, because these industrial fumes will be having chemicals and will create an issue. Their physical properties are not being talked here now. These are melting point as between 258 to 268 degrees centigrade, specific gravity between 1.38 and 1.43. Glass failures, they are 33 plus minus 2%. The Rockwell hardness defined as 110 minimum, tensile strength 17.5 kg per m square minimum, elongation a bit lesser 10% maximum, cross breaking strength is 20 kg per mm square minimum, and the dielectric strength is 11 kV per mm minimum, and volume resistivity is 10 raised to the power 8 ohm centimeter minimum. So, these are the different type of the physical properties which needs to be checked when GFN 66 liners, glass filled nylon 66 liners needs to be used on the tracks. So, with this we close our discussion today. What we discussed was the fastenings related to the rail and sleepers, and we started talking about the requirements of the elastic fastenings, and then we have specifically taken up the rubber pads, the CGRSPs, nylon cord CGRSPs, metal, and the GFN6 liners. Thank you. We will be meeting again in the next lecture.